Hi and welcome back. This is now class 8 of this series of tutorial. In this class, we are going to finalize our simulation workflow all the way up to render. We will still not focus on the artistic part yet, but rather work on the technical side. Once your full workflow will be ready, you will see that it's easier to do wedges and tune the look of your simulation. So the first step is to come here inside our geometry. Remember that this one, the dust geometry, is importing the data from the top network. Okay, all the simulation data is imported here, thanks to the import field. By default, with the smoke preset, we have these fields imported. But in our case, we don't have any CD field, the color field, we don't have it, so I can get rid of it. Same for the temperature, I don't have it, so I don't want to cache it. The rest field is a field that is used mainly during render with Mantra. On the shader, you have an option to activate some noise. Maybe we'll do that later, so for now, I don't need it either. Now, density and velocity. So obviously, the density is to keep because this is the one that we are going to render. Now, the velocity is used mainly in our case for motion blur. You could use it as well for advection, but we are not going to do that. I'm going to use mainly for motion blur. But while I'm still doing some wedges, I don't want to cache the velocity. Why? Again, it's because I'm going to clutter my disk and I don't want that. So I could get rid of it, okay? Do my wedges and then bring it back in when I'm going for the final render. Now, for the sake of this setup for this class, I'm going to leave it here for now. So I show you how to fully set up your cache and the render, and then I'm probably going to get rid of it for the wedges. Now let's cache this. So, well, you know me now. I'm a little bit lazy, so I'm going to copy paste this because I have all this set up already. All right, so I'm going to plug this here because this is the one I want to cache. I'm going to get rid of this. And here I don't want the time warp for now. I want the file only, which I'm going to plug to the render. And here I have my 16-bit, and this is already set up correctly. Before doing the 16-bit conversion and the cache, we need to do a few things here. If you middle click on the import fields, you notice that we have 4 volumes here: density, vel x, y, and z. Volumes here, like this in green, are Houdini native volumes, and we don't want to cache Houdini native volumes. I mean, they are not as optimized as the VDBs in terms of disk space. The VDB format have an algorithm where it doesn't write anything which is completely empty. Okay, so there's no data written to this for this part of the container that are completely empty around the smoke. So I'm going to do a convert VDB node here. I'm going to place it right in the middle here. I'm going to do this, and then you see here that we have 4 VDBs now, and it's in blue, and we have density, velocity x, y, and z. These 3 components are separated. Okay, we have 3 float components, and I would like to merge them into one single vector field. So I'm going to do a VDB vector merge, okay, which I'm inserting here. And by default, it's already working. You just have to change this displacement to velocity and to displacement, velocity, acceleration, and now you have the velocity merged, all the component merged into one single field. Okay, and then the rest is fine. So I can do a cache now and read this back here, which I'm going to do right now. So the cache is done. I moved my display flag with the volume visualization here onto the file read, and you can see that we are actually playing the information from the cache. Now we don't have any information before, and you know we need to do a time warp. Okay, so I'm going to do this time warp here. I'm going to say frame 31, so I'm not retiming anything. And then I need to plug this and do this. And now if I display this, I should be working correctly. We still see something here. I don't know if you notice. So what I'm going to do is I'm going to say, okay, before frame 31, you want to display nothing, and then we switch to the cache. And the way to do that is I create a null that I'm going to call nothing. Okay, and then I do a switch. And I'm going to say switch from nothing to time warp, and I'm displaying this. And so before frame 31, I want the switch to be on 0, and then I want the switch to be on 1. Okay, it seems to have disappeared now. Maybe I had some display issues, but I'm going to keep doing this. So you want to say before frame 31, it's 0. After frame 31, it's 1. So the expression for that is $f greater than frame, or greater or equal to frame 31. Okay, so when it's before frame 31, you have 0, and then you go all the way to frame 31, it starts at 1, and then it displays the simulation. And then you want to plug this here. Okay, and let's do a little automatic cleanup. It doesn't really work, sorry. So doing this, putting it here, putting the nothing here, should be good like this. Okay, now looks like a little mess here, but it's quite useful. So you have no error message, and it's smooth when you play it. Okay, this top import here is the visualization one, remember, so I'm going to call it visualization and keep it here. And so we're good, we have the cache, and we can work now on the rest. So while I was offline, I set up the render for you. So here in the material, I added a pyro shader. Okay, not the pyro shader core, the pyro shader, because the pyro shader is built on the pyro shader core here. And it has some other parameters that are interesting us. So use the digital asset pyro shader instead of the core. Here on the object, I defined the material, obviously. The lights were already here, and inside the ROP, I added this mantra ROP. Okay, I called it dust. I set up the basics like the frame range, the camera, the naming here. And then I changed the object here. For the moment, I have just dust, and I used the key light for rendering. And so this is the render we have. Okay, at frame 100, this is what we have. You can see it's a little bit noisy, but this is the default setup we have with the mantra ROP. Now on the mantra ROP still, go to the rendering tab, and we are going to talk a little bit about the render engine. By default, you have ray tracing. This is the image you have. I'm going to do a snapshot here. You can also go with micro polygon rendering. You see that we have an image which is much less noisy at this time, and if we do a snapshot, then you see we have a 2-second render time, so it's actually faster to render. If I kill and restart, maybe it takes a little bit more time, but for the amount of noise, the difference of noise, the micro polygon rendering is still winning at this point. You see 6 seconds, and we have 7 seconds here. But I tend to, I mean, from my experience, the ray tracing, even though it's slower in terms of render, gives me a sharper result than with the micro polygon rendering. And also setting up the micro polygon rendering with shadows, so you have to go and set up the depth map shadows on each light and render them. I don't think it's worth the pain of setting this up. Okay, the difference in the time, the render time, is not worth the pain for me. Okay, so that's just a disclaimer. According to my experience, my test, I prefer to go and work directly with ray tracing or PBR rather than micro polygon rendering. But you could consider micro polygon rendering depending on your machine, depending on your test, maybe to just do the setup. Quickly, you set up the light, you set up everything with micro polygon rendering, and when you go for final render, you can choose the ray trace. or the micro-polygon rendering if you think the look is actually fine with what you want, okay? So both are good, okay, micro or ray tracing. Just know that this one is faster, but has a little extra cost of setting up the lighting with the depth map shadows. The ray tracing is slower, but has a crispier look on the volumes, which is sometimes interesting, depending on the volume, obviously, that you want to have in your final render. Just one thing I forgot to mention about the micro polygon rendering here. If you're using this and you want to do your test renders inside the render view, you have to deactivate the preview here, this preview button. When you do micro polygon rendering without this, you see that here we have the micro poly. It specifies which render engine it was using. If I activate this, kill this, activate the preview mode, and now do render, you'll see that we'll use the ray trace mode, the ray trace render engine. Okay, the preview mode here needs the ray trace to be able to do the refining, the preview refining here. Okay, so you won't see any micro polygon rendering settings that you would set up here, because it's forcing the ray trace to be able to use the preview. So if you work with micro polygon rendering, you want to deactivate this, okay? It's not mentioned in the documentation. I had to ask the support for that. So at least you know, and you don't spend too much time trying to understand why you don't have the result that you are expecting. Before getting to play with those parameters here, I would like to do a little bit of recap on how the render engine is actually working. So you go to the documentation at this address. You have a very good page about how to render using Mantra. The page that really interests me at the moment is the sampling and noise. And if you go to this page, you have this animation about how the Mantra is casting some rays inside the scene to do the rendering. These are the primary rays, okay? The primary rays are mainly used to get the shape of the object. So you send one ray, you hit an object, and you write it here on your image. Obviously, the more rays you send, the more defined will be your object inside the final image, all right? And you can see here, it's even better. How do you define those rays, those primary rays? You define them here in the pixel samples. Okay, you send 3 pixel samples in X direction times 3 pixel samples in the Y direction. If you want to see how it goes, you go to the Mantra sampling parameters here, and you have an explanation here of how the pixel samples are used, and 3 by 3 gives you 9 rays sent, and here 6 by 6 give you 36 rays that are sent per pixel. Okay, remember this is per pixel. All right. So primary rays, you cast some rays, and you get the shape of the object, and you define this here. Now, for each primary ray, you have secondary rays that are cast inside the scene to get the information of the lighting. All right, and those secondary rays, you can divide them into direct and indirect lighting. The direct lighting is explained here. This is the ray that, these are the rays, the secondary rays that deal with lights, okay? So here you have the rays that are going to go and get the actual lighting from a proper light, all right? So the secondary rays are dealing with this, and this, all right? And the secondary rays are defined here with the rest of the values, and here with the limit as well. So if you go here, then after the direct rays, you have the indirect rays, and this is the indirect lighting. So you're not looking for a light, you're looking for the bounce of the light onto the other object. You are looking for the refractions, for the reflections, etc., etc. Okay, and this is where you define the quality of the secondary rays with indirect lighting as well. Now, to help you define and tune your rendering with the different options we have here, you can go here to the Image tab, Extra Image Plane, and we are going to add the direct lighting and the indirect lighting. Okay, these are going to create some AOVs, and when I'm pressing Render here, okay, the image is going to generate. Open this menu, if it's not already, and here you have access to all the AOVs. All right, so this is the main color. This is the one we are seeing now. And then you have all the direct lighting here. Okay, so for instance, the direct volume here is exactly the same as the color. And you can go through them and see what AOV, what direct or indirect pass is actually giving the noise here. So we see here the direct volume is responsible for a big part of the noise. Let's go and check for the direct diffuse. Okay, we have nothing here. Just to make sure, you open this menu and you can click here to increase this or go crazy. And we see that we don't have anything here. All right, let's check now the reflection. We don't have anything either. All right, and let's check the other ones, and you will see that you don't have anything inside for all the different contribution for the components of the light. And let's look at the indirect as well. So this is the indirect diffuse, reflect, coat, refract. We have the volume. Even the volume is empty here because we don't have any indirect lighting from any volume or from the volume itself, and we don't have anything in the SSS. So what does this mean in our case? That means that here we can get rid of all the parameters that are not useless to us. The SSS we don't have, we get rid of it. Diffuse, we don't have it. The reflection quality, we can get rid of it. Okay? So this leaves us with the volume step rate only and the volume shadow step rate that we are going to talk about later. All right, but at least we know that here we can go all the way up to 0 because we don't down to 0, sorry. We don't have any information there that is useless for us. If you go to the second tab here, the limits, you can also reduce the reflection limit because there is no bouncing of the light and any reflection inside the volume, and same for the refraction. Okay, we've seen that we don't have any diffuse. We can, if we go and test this, let's go for the indirect diffuse. We see we don't have anything. All right, so I can get rid of this as well. The SSS, same. The volume limit is by default 0, okay? So maybe we are going to increase it later and see the influence of the bouncing of the light inside the volume. But at the moment, I don't want it, okay? It's obviously costing quite some time in rendering, and at the moment, I want to do a quick setup. This will probably be used at the end when I want to improve my rendering, but maybe I won't need it either. So at the moment, I'm going to leave it this way at 0. That means that here, this leaves us with just the volume on this tab, and we don't have to bother with any other information. And so here, when I go back here, I know I don't have any indirect lighting. Okay, all the indirect lighting is black, and I don't want any volume scattering. Remember, sorry, just go back here to limits. Volume scattering is this one, the volume limit. I don't want this, so I can safely remove the indirect lighting per component, okay? And here's the direct lighting. I want it, obviously, but I don't need all this, so I'm going to get rid of it. All right. And now this leaves me with just a direct volume here. Why the direct volume is empty now, and we don't have it in CD. Okay, where are you? Was it indirect lighting for volume? Direct volume and direct volume. Okay, I'm going to kill the render here and launch it again. Maybe it needs to refresh properly. Let me see that. Come on. Let's see. This is the old render. Come on. And now we have the direct volume. Okay, so this was it. Okay, it didn't like the activating or deactivating the AOV without killing the render and rendering again. So now we have this. So we just seen that we don't need any secondary rays for the indirect lighting inside the volume, at least at the moment. The other reason we could need secondary rays is for the direct lighting. Remember the direct lighting here, if you go to the documentation, direct lighting is all the rays that are sent directly to the light, okay? And the light are here. Now, regarding volumes, we can say we have two types of light. One type is this kind of light, like the distant light, or the point light, or eventually the spotlight here, okay? This is one kind of light because with this light, you only really need one sample to get the information from the light. Let's think about it. Let's say a point light. We need this point here and this point, and we have one vector. Okay, so at this point, there really is only one ray you can cast to get the information from the light. Any other ray is useless because you get the same information. Okay, now the spotlight is the same. It's just that it has a cone shape. So some of the vector, let's say the cone is going like this. Points here would get the information from the point. Points here would not get the information. But still, we only have one vector going from this point to this point. And regarding the distant lights are lights for which the rays, the light rays are all parallel. They are all going in the same direction. So really we only have one vector as well. So we only need one ray to sample the light. Okay? On the contrary, and if you look here at the environment light, or if you go for a light here that is anything but a point or a distance, like the line, the grid, the disk, anything that has a surface, like the sphere or the geometry, those lights need various samples to be able to get the proper lighting information. Let's think about it. Let's say we have a grid here or any other object, okay? A point here would need to get the light from this part of the grid, but also this one to get the full contribution of the grid, okay? So it needs to send several rays to get the proper information from the grid lighting this point at this position, all right? So here we need more secondary rays. All right, that's why we have two types of lights for rendering volume. So the one that need just one secondary ray for direct lighting, and the one that need more than one. Okay, and actually, if you go to the environment light or any other light, let's say a light, and I set to a sphere. Okay, you can see, well, you already seen it, the sampling quality has been activated, and here you have also, on the render option, you have a sampling quality. And if you look at the help there, you see that this sampling quality is a multiplier for the light that will multiply the ray sampling parameters that are on the ROP, the mean ray samples from the output driver. Okay, so if you go here, these are the two parameters that it's going to multiply to get the information, the proper information. Same here, this sampling quality is the same, okay? So what does this mean for us? That means we should work as much as possible with light that need only one ray sample. That will speed up our render big time, okay? If you really need a real light or an environment light, just know that it will cost you more secondary rays to avoid some noise, okay? So what I recommend, when you do your setup, try as much as possible to work with distant lights, point light, or spotlight, okay? And if really you need, then at the end you can include some environment lights in your render, but I would recommend seriously to avoid that, because you would have like a really long and expensive render time. So now we know that we don't need secondary rays for the indirect lighting, and we know that if we keep working with distant light or point lights, we don't need secondary rays as well for this direct lighting. So I'm going here on the mantra ROP, and I'm going to go here to the ray variance anti-aliasing, and if I deactivate this, you'll see that I get rid of all the parameters that were here. And those parameters are here to help you fine-tune the mean and the max ray samples for the number of secondary rays, okay? And you go between mean and max because it calculates automatically, according to a noise level that you are giving it, how much ray it needs to sample, okay? So it looks at the noise level in the image and it says, okay, it's good, so I can stop sending ray samples. Or on the contrary, oh no, it's not good enough, the noise is too high, then I need to send more rays up to the maximum rays I need to send. But here in our case, we don't need that because we know we only need one ray sample for the direct lighting. So I'm going to deactivate this. And really, that means that the render of the volume at least at the moment, because we don't need the bouncing of the light inside the volume, or we don't need any secondary, indirect lighting from the environment onto the volume. At the moment, we only really need those parameters to do the rendering of our volume. Okay? So we are going to go through this. And if you go back to the documentation, documentation is here. If you go back to the documentation and you go all the way down, you have a part about volume, sampling the volume. And this is going to explain you how the volume are sampled inside the render. So the first thing is the primary rays that are sent from the camera. They need to go through the volume, okay? And they need to sample the volume at different places to be able to get the sense of density here, all right? So every point here means that you are sampling the volume to get the proper density, the proper transparency. And this one, you tune it here, the volume step rate. The volume step rate means, okay, how many voxels do I skip when I do some sampling, okay? So you can read the documentation here. It's basically a value of 1 means I sample every voxel, okay? Every voxel, 1, 1, 1, I sample them. A value of 0.5 means I sample 1 voxel out of 2. A value of 0.1 means I sample 1 voxel out of 10. So here that would be the first voxel, voxel 1, and then 2, 3, 4, up to 9 are not sampled, up to 10 are not sampled, and then 11 is sampled, and then you go all the way to 20 and you're not sampling anything, and then you go you sample 21, etc., etc., etc. Okay, and this is this value, and by default it's 0.25, which means it samples 1 voxel every 4 voxel. Then you have the shadow step rate, which is the same, but for the shadow. Not exactly the same though. This one is a multiplier on this one. So if you multiply by 1, that means it's using exactly the same step rate to do the shadow. If you multiply by, let's say 10, that means you have 2.5 here instead of this. So it's going to do 10 times more sample than this. And if you multiply by 4, that means that you are doing 1 sample every voxel, while here you are doing 1 sample every 4 voxel. So you are sampling more shadow information than the volume itself, okay? So it's just a multiplier here, all right? And this is what it's doing here. And then for each sample here, you are sending a secondary ray. And because we kept it, we know that we just need 1 secondary ray. It's going to send 1 ray per sample to get the lighting information there. And now, one last parameter that is really important is the stochastic transparency that you can activate or deactivate. And you have the information here, how it works. The stochastic sampling is helping removing the noise in the transparency by randomizing these samples in a stochastic way. And doing this, it helps reducing the noise that you can have inside the render. All right. So what I'm going to do is I'm going to do some test render wedges to show you the different results we have with these values. So I did some wedges rendering the smoke with the stochastic samples parameter and the volume step rate parameter as well. I started with the default values here, and this was the result. And then I multiplied here the stochastic sample by 2, and I had this result. And then I multiplied it again by 2, so I had 16, and this is what I had. And then 32, and this is the result I had. So you see that the noise is disappearing slowly. And then the final test I did, so it was 32 here, I did a test with a volume step rate of 0.5, so 1 voxel every 2 voxel, and this is what I had. So you might not see the difference on your machine, okay, on the video, because the video is compressed, but you might be able to see it on your machine, so I invite you to do the test for yourself. Now let's look at the render time. You see that it's not adding much. It might be in terms of milliseconds, and here we are going to 8 seconds for the render. So keep in mind, though, that this is because my simulation volume is of low quality. Maybe when we increase the volume, the simulation quality here, we might have more difference in terms of render time, but it won't be like multiplying by 2, by 4, or by 8 the render time. It will add some time, but it won't be too much. It will still be acceptable, and still it will improve the noise quality here. Okay. Now, if you want to have more information about this, you can read this, the last part of this documentation here. It's about the stochastic transparency. What it says, it's basically there is a variation, that the variation in the color, in the shading, is less obvious than the variation in the transparency. And this is what the stochastic sampling is using. So the stochastic sampling is working on the transparency instead of the shading, and the step rate is working on the shading. So you have this value collecting shading information, and this value is collecting transparency information. All right, and so it does it in a stochastic way to reduce the amount of noise, and it decouples that so that we don't have the same amount of samples on the shading and on the transparency, and it goes faster. One last thing I forgot to mention about the stochastic samples is that I recommend you start playing with the stochastic samples before playing with the pixel samples, okay, to reduce the noise here. You see that how much we reduce the noise with a stochastic sample of 32. You can first work with this rather than with the pixel samples. This will cost you more in terms of render than this, and it will add, I think it will reduce the noise a bit less than the stochastic sample. So first play with this, and then you can increase the pixel sample if you need. And another thing I did not mention, but obviously if you have a really opaque dust, okay, it's really dense and you don't see through it, like pyroclastic volumes or really dense dust from an impact, you can reduce that. You don't need that much of this, okay? Because it's dense, so the ray is not going through the volume too far, and so you don't have too much transparency to compute, and so you don't have that much noise, so you can reduce that, and you don't need that much sampling, so it goes faster. And this can help you also choosing your render engine, because obviously if you have something which is really opaque, then you don't need much rays to render, so you can go for ray tracing with your render of choice, because it would be fast enough with really nice details. If you have something transparent, then it's worth testing the two, because the micro polygon rendering might be a bit faster. Okay, so the quality of the smoke, the look of the smoke is also a good indication of what to choose as a render engine. Okay, so I prepared this scene for you that I will save as class 9 start, so you have the same render setup as I have for your wedges and simulation. I added those two lights, okay, a rim and a fill. We want to see where they are. Here they are, the key. The rim is here and the fill is here, okay. Then what I did is on the rope, obviously I added them, okay, in the light. I also added the object as matte, so we have the fragments inside the smoke that are holding out the value of the smoke for the render. Then what else? I came here on the extra image plane and I added some extra image plane here, custom. So I cleared it now. I'm going to show you how to add it. You press the plus here and then you select here the direct lighting. It's not the same as this one, which this one is per component. You can select this one, and I would like to use this option to export variable for each light. Okay, and now you will see during the render that we have one AOV per light about the direct lighting. And one last thing here, on the shader, I use a density scale of 10. I used basically the value that we put here in the volume visualization, or this value here, which is the same, the volume visualization. It's a good starting point. It's a good indicator of what you need for the render. So that's what I set here on the shader, and then we fine tune later. But it's a good thing to start with. The thing that you have in the preview gives a good indication. Okay, and then now, so let's go to the render. This is the render I have for frame 100. And these are the AOVs, so the direct lighting is here, and then we have 1 AOV per light, and you can see the contribution for each light. Okay. Now, still regarding the light, I need to tell you a few things. So the key light is set to ray trace shadow on everything. The rim light here is set to ray trace shadow as well, but just on the dust, because I don't want the shadows from the fragment on the rim. Okay, there's just one direction of light. And the last one is set to no shadow. Okay, so it's not that it won't cast any shadow in the end, but right now I want to have a fast turnaround, as I told you. I want to do some quick iterations, and so I'm trying to still optimize the render. So I don't want shadows on this. I could also save the shadows from the rim, but I want some information at least of the volume to give an idea of what I will have in my final render. And the rim is going to give me more information than the fill in the end, because this one tends to be lower. So I keep the shadow on the rim first, and then I will probably activate the fill later. All right, so at least this goes faster. And well, that's it. I'm going to launch the full render, the full frame range with this setup, and I will show you the result in a minute. And there you go. So this is the full frame range render of the smoke that I did with this setup, and I saved this setup into a class 9 start file, so you can have it as well. This is an image sequence. You can see EXR, and so you have all the AOVs, and then you can see the contribution of each light on the render. So a few things to remember from this class. The first thing is that while you are setting up your render workflow, you need first to cache, optimizing the volume, and then you need to set up your render. While you're doing this, I recommend you're working with the lowest quality setting as possible. Okay, so work with low quality setting for the simulation. Okay, it doesn't have to be too coarse, but you can go from low to mid. If it's too high, then you will have long render time, and it would take longer to set up, and you're just setting up something, so you need to go fast to position your lighting and set up your parameters. So that's one thing. Go also with the half resolution, because you don't need the full resolution right now. So even quarter resolution if you want, that will help you go faster, and use the lowest possible values on the sampling. So you have a good quality, but not too much, so you can accept a certain amount of noise at this step. Then yes, with the light, you should use the point, spot, or distant light. Okay, because they are much faster to process. Avoid for now the environment lights or the area lights, because they need much more sample, and then either they introduce a lot of noise, or you will have to wait longer for your render. Finally, here the values that are important are the pixel samples, the volume step rate, volume shadow step rate, and the stochastic samples. The pixel samples go for the primary rays, okay? So don't go too high first with this. Play first with the volume step rate, okay? Increase this. This is like the shading quality for the geometry. And so first play with this one, and then increase the pixel sample at the end. This one deals with shading, and we have the stochastic samples here that deals with transparency, okay? So if you have like a really transparent smoke, then you can increase the stochastic samples. It will reduce the noise that you have because of the transparency, but still you can leave this value separated from this, and that way you have a different value for the shading than for the transparency. And that's it. That concludes this class 9. Thank you for watching, and I'll see you for class 10 soon. Goodbye.